when you took the basic statistics last semester, you have learned, or at least you have been introduced to the concept of hypothesis testing. I'm going to be very quick and brief, okay, in this review. Okay? And hopefully starting next week, we can get into the actual regression analysis. Okay? All right, so here's the note. And yeah. Hypothesis testing, in the last semester in basic statistics, let me give you some, well, since it has been a long summer, I'm sure some of you forgot some basics concepts, right? From my experience as a student, as soon as the final exam is over, I deleted all the memory, purged all the memory. Okay? So let me just try to. First thing we mention in statistics is population. Okay? We typically use a rectangle to represent the population. Okay? Population includes every observation, every element of interest. Okay? So, if you want to understand anything about, say, Hanyang University students, okay? For example, you are interested in what's the average height of male students at Hanyang University, okay? Then the population will include each and every male student in the entire Hanyang University. I don't know, maybe 20,000, 30,000, I don't know, total numbers. Okay? So that's this rectangle includes the population. Okay? So what we are looking for is, say, average height, okay? What we call population mean, okay? Or population parameter. Okay? So there are population parameters. Typically, mean, proportion, okay? Or sometimes standard deviation. Okay? Those are typical population parameters that we are interested in. Okay? Say, what's the mean height of the students? Well, what percentage of students are pro-choice? I guess you're not familiar with that term, right? I say, I guess, between the Republican Party or Democratic Party in Korea, there are 새누리당 and whatever, 새정치민주연합, whatever, right? So sometimes you may be interested in the percentage or the proportion. Okay? All right. The trouble is many times population is too large. Okay? So if you really want to take the population mean, right, then you have to add up all the heights divided by number of observations, right? So add up all the heights of all male students and divide by the number of male students. Okay? So first of all, it's going to be a lot of time taking. You have to spend a lot of time, and then it's very costly. Okay? And sometimes it's just not possible. How do you locate every male student in Hanyang University, right? So what we do in practice is we take a small sample, right? So here's the population versus sample. Okay? And then there's population parameter versus sample statistic. Okay? So we calculate take a small sample, maybe collect information on 100 students, okay? And calculate the sample mean or sample proportion, okay? And so on. Okay? All right, that's the idea of statistics. Okay? So in the last semester, you probably learned that there are two basic areas of statistics. First one is descriptive statistics. Descriptive statistic means you collect all the data and analyze all the data and come up with the reports like mean, standard deviation, or whatever, the description. So you can describe the data with numbers, or you can describe the data with pictures, like tables or graphs. Okay? So those are the things we did in descriptive statistics. Okay? What's the other part of statistics? You still remember? In addition to descriptive statistics, we have, nobody remembers. Just erased clean, huh? Right? Any idea? Anyone? Making a guess? What do we call that? Right? Wow, okay. It's called the inferential statistics. Okay? Inferential statistics or statistical inference. Okay? So what that means is, well, so we collected the data, sample data, and calculated the sample mean, right? And based on that, we are going to make a guess or conclusion on population mean. Population mean is unknown parameter. We just don't know because there is, it's just too costly or impossible to collect all the information on every observation in the population, right? So population mean is unknown. There is no way we can actually know the population mean, right? But based on what we know, sample data, sample statistic, right? We're going to make a guess on population mean. Okay? That's the idea of inferential statistics. Okay? Making a guess. Okay? So that's why we need to learn statistics. Okay? Because depending on how you do that process, how you handle that process, you can either come up with the right answer, correct answer, or incorrect answer, right? There is a certain way you have to do this process, right? So for that purpose, you need to understand the distribution, how the data points are distributed, right? And how to apply the concept of distribution. And there are some assumptions we have to make. There are some things that we have to be careful, right, when you make this inference, okay? And if you don't know how to do that correctly, then you can come up with the wrong answer, right, incorrect answer, right? And when you apply this idea to, medical science or shooting the rocket to the moon, right? The rocket can go to somewhere else, right? Completely missed in the space, right? So you can come up with, you can actually create very serious mistake, right? If you don't do it right. Okay? So that's the whole idea of statistics, so descriptive statistics and inferential statistics. Okay? As a part of inferential statistics, you probably learned two separate processes. Okay? Interval estimation versus point estimation. Okay? There are two different ways you can do inferential statistics. Okay? Interval estimation, what is it about? What are we talking about here? Interval estimation. Come on. You don't have to be shy, right? What are we creating or finding in the interval estimation? What is CI? Confidence interval, that's right. Confidence interval, right? Remember that? Right? 100 times 1 minus alpha percent confidence interval, okay, is what? X bar plus minus, depending on what distribution you use, S over square root of n, T alpha divided by 2, right? Right? Something like that, right? So in interval estimation, okay, we're trying to, even though we do not know actual number for mu or population mean, we're trying to come up with certain range or interval where we are, say, 95% confident that actual mu exists. Okay? So even though we don't know actual number, right? At least we are some percentage confident, 90% confident or 95% confident that it's between this number and this number, right? That's the one way to come up with this, the estimation or making a conclusion about the population mean. Okay? The other way, point estimation, is hypothesis testing, right? In hypothesis testing, we actually try to pinpoint the value of mu. Okay? So we set up two hypotheses, null hypothesis versus alternative hypothesis. Okay? And null hypothesis claims mu is, say, 5'7", 5'7". Okay? Let's say null hypothesis claims that the actual average height of Hanyang University male student is 5'7". Okay? And then alternative hypothesis always negates or says the opposite. Okay? It's not. Okay? And then based on the evidence, we can either reject the null hypothesis or not. Okay? That's the basic idea of the hypothesis testing, right? And that's what we're doing with the point estimation. Okay? So here, example, the monthly mean or monthly cell phone bill in the city is $42, right? And you can use the proportion as in case you are interested in proportion. Then the null hypothesis could be something like pi is 0.35, whatever, right? Against the alternative hypothesis. So starting with the null hypothesis, there are a few things you have to know. Okay? When we start out this entire hypothesis testing, we start out by assuming that null hypothesis is true. Okay? Until we have sufficient evidence to reject it. Right? So the entire test is run with say mu is 5 or 5'7". Okay? So what they're saying is, if null hypothesis claims the average height is 5'7", right? Then we are assuming that the entire, of course, there will be some short people, tall people, right? But the distribution is centered at that number, 5'7". Okay? And based on that, we're going to evaluate the result data, okay, and make a conclusion. Okay? So keep that in mind. Right? We start out by assuming that the null hypothesis is true. Okay? Always contains equal sign. Okay? So null hypothesis either has equal, greater than equal to, or less than equal to. Okay? You can have 3 different cases for the null hypothesis. Okay? Okay, the final point here. May or may not be rejected, but should never be accepted. Even if you cannot reject the null hypothesis, you cannot say you accept the null hypothesis. Why? Yeah, so we recommend that even if you cannot reject the null hypothesis, you should never say accept, because there is a risk of what error? There are only two types of errors, right? Type 1, type 2, which one is it? Type 2 error, right? Because type 1 error, we take care of it by setting up alpha level, right? But in introductory statistics level, right, we don't do anything about the type 2 error, right? So just our recommendation in this course is either you reject it. If you cannot reject it, just say do not reject or cannot reject. You never accept it. We'll talk about it in detail, maybe next class. Okay? Alternative hypothesis is the opposite. It always says the opposite of null hypothesis. Okay? And so it contains not equal to, less than, or greater than. Okay? So depending on your null hypothesis, okay, if your null hypothesis says equal, then your alternative hypothesis should say not equal. Right? If it's greater than or equal to, then the opposite is less than. Right? If null hypothesis says less than or equal to, then your alternative hypothesis should say greater than. And as you see here, alternative hypothesis cannot include equal sign. Okay? Either it's not equal, less than, or greater than. Okay? And this is generally the hypothesis that the researcher is trying to prove. So in reality, in practice, they recommend that you set up the alternative hypothesis first, okay? And then just say the opposite as the null hypothesis. Okay? Here's an example. This is the last thing that we're going to do, last slide that we're going to do today. There was a Hyundai-Kia fuel efficiency controversy last year. Do you remember? Here's the Wall Street Journal article as of November 3rd, 2014, last year. The story is the Hyundai and Kia Motors in the United States have been found guilty, okay, for overstating the fuel efficiency of their cars. Okay? So the U.S. government have slapped fine of $300 million, okay, for this company. Actually, Hyundai and Kia are one company, actually, right? That's the story here. What did I do? Okay, forget about it. Anyway, and I find out that actually in Korea there was the same discovery or controversy about a few months earlier. Okay, so this is a Korea Herald, June 26 last year. Okay? And it says the Transport Ministry on Thursday announced that it would slap fines on Hyundai Motor and Sangyong Motor for reporting inaccurate fuel mileage rating for their sports utility vehicles. So apparently it's just not just Hyundai and Kia, but some other companies were doing that in Korea. Okay? And actually, in Wall Street Journal article, the problem was discovered with the Elantra model. Okay? Elantra is in Korea. The model name is Avante. Okay? They call it Avante in Korea, okay? But in the United States it's called the Elantra. Okay? So it's a very popular car, and I was actually interested in buying one So here's brochure, e-brochure of that vehicle. And as I said, I came to Korea in 2012, 3 years ago. And until then, and apparently until 2 years ago, they claim that Elantra could go 40 miles per gallon, which is pretty good, pretty high. Not many cars can drive 40 miles on 1 gallon of fuel, of gasoline. Only the hybrid like Toyota Prius. Toyota Prius actually goes 60 miles per gallon, but it uses half gas and half electricity. But for the full gasoline cars, 40 miles per gallon is extremely good value. But this is the new brochure for 2016 model. And anyway, I see that they changed their claim to 38 miles per gallon from the 40 miles per gallon. So what could have been happening? I mean, if EPA in the United States, Environment Protection Agency, EPA, if they want to claim or provide the evidence that the Hyundai and Kia's claim is overstated, right? Then not an alternative hypothesis would have been this, right? So mu is less than 40 because Hyundai and Kia are claiming that it's at least 40. Okay? So the average gas mileage, Hyundai Kia is claiming that it is at least 40, it can go 40 miles on a gallon of gasoline. But the researcher at EPA set up the alternative hypothesis this way. And apparently they did the repeated testing on, I guess, a few different cars, and they found enough evidence, sufficient evidence to reject this claim. So they have sufficient evidence to support the alternative hypothesis. So you can imagine, similar concepts in many different areas. Basically, all the medicine, drugs developed should go through this testing, right? Effectiveness testing or safety testing, right? So, that's the idea of hypothesis testing. Any question today? We're going to stop today here, and I'll see you back on Thursday. Okay?